Hello, so we're going to begin our understanding of geometry by talking about points, lines, and planes. We're going to talk about basic terms, what they mean, and how we can use them. So some definitions. So a point is a location in space. It has neither size nor shape. Pretty much we use it to designate certain areas where things are meaningful, like certain endpoints, things like midpoints, intersection points, points on the graph, stuff like that. They're not actual shape, not have an actual size. They just designate somewhere where we're talking about in that particular moment. Now, a line is made up of a whole bunch of points, infinite number of points. It has neither thickness nor width. It cannot be measured because a line goes on forever in one of those directions. It is one-dimensional. Whereas a plane is two-dimensional. It's a flat surface made up of a whole bunch of points. It extends infinitely in all directions. So in a 2D direction, at least. So we have our length. So we're going left and up, or down and out, or whatever. So those are your three basic definitions. And a lot of geometries revolve around using points, using lines, and using planes, and then specific types of points, lines, and planes. In particular, collinear points. These are points that lie on the same line, whereas coplanar points are points that lie on the same plane. You should be able to figure that out based off how the definition starts off. Collinear, coplanar, hints exactly is what's going on with these particular points. So what we're going to do is now we're going to identify certain collinear and coplanar points based off our box diagram right here. So we have our points on our vertices A, B, C, D, E, F, G, H. Let's add some other points. Let's put a point right here, which is going to be point J. Point here, which would be point K. One here, which is L, and then one more. So if I want to identify collinear points, well, these will all be points that make up the same line. So for example, A, M, B would all be collinear points. B, J, C would also be collinear points. The same with C, L, G, and H, K, G. All those situations are points that are all on the same line, therefore that makes them collinear. Now, if they're collinear, it does not necessarily make them coplanar. For example, A, M, B, J, C, all 5 of those points are not on the same line. A and B are on this line, and then J and C are on this line with B. So they share point B, but they're not together on that same line. However, while A, M, B, J, C are not collinear, they are coplanar, because they all form that top surface right here. So, same token, E, F, B, M, A are also an example of coplanar points. They all form that left surface. Now, if I want to talk about points H, K, G, D, J, those will not all be coplanar. Whereas H, K, G, and D are coplanar points. But if I include point J in with that group, there's all 5 of them not coplanar, because J is on the top surface or the back surface, whereas D, G, K, and H are all either on the left surface. It's not going to really, or sorry, right surface. So it's not going to work out as coplanar points. Alright, so those are your basic definitions of collinear and coplanar points. We'll get into much more interesting stuff as we move on. Take care.